Hello everyone, my name is Thabo Hlatshwayo, and I'll be sharing with you some of the road ecology work that we are doing here in South Africa. My presentation is titled Exploring Wildlife Crossing Effectiveness on the N4 National Highway in South Africa. Transport corridors such as roads and railways are essential for connecting societies. Our daily movement requires the presence of network road systems. However, when these roads are built without considering the sustainability frameworks, they pose exactly the opposite effects for natural systems. By crisscrossing the natural landscape, they fragment ecosystem and critical areas for biodiversity, which reduces ecological connectivity significantly and accelerate losses of biodiversity in terrestrial ecosystems. The African human population is rapidly expanding, which makes Africa's transport development agenda to be seen as a catalyst for economic and social development. To implement the African Continental Free Trade Area, investment for developing transport corridors across Africa are growing. But what does this mean for Africa's natural landscape and its biodiversity? This means that more of the landscape is going to be fragmented, which will result into losses of habitat for wildlife, which will often form barriers, which will cause or alter animal behavioral change, as well as increases the rate for wildlife roadkill, which all of these collectively will increase the risk for extinction. Currently, South Africa comprises of an extensive network of roads with approximately 750,000 kilometers of road corridors that intersect our country's natural landscape. While majority of these roads cut across important biodiversity hotspot areas, the restoration of ecological connectivity in transportation planning is still overlooked in our country, which subject terrestrial biodiversity into severe threats. Despite empirical global research on the usefulness of restoring ecological connectivity in transportation planning through implementing wildlife crossing corridors, the acceptance and adoption of ecological connectivity in transportation planning in South Africa still faces enormous challenges. To cover this gap, this study has explored animal use of existing underroad drainage culverts by wildlife using camera traps in one of the busy highways in South Africa. As part of our methods, we have identified 7 underroad culverts that are located within a roadkill hotspot along the N4 National Highway. 2 camera traps were deployed in each structure, except for one bridge which was monitored using 4 camera trap devices because of its wideness. The structures were monitored from December 2022 until October 2024. In this slide, we are demonstrating the location and the arrangement of the culverts along the N4 highway as shown in the map. It is important to note that culvert 2 had a roadside funnel fencing, which was basically to improve or to measure the influence of fencing on the intensity that wildlife will use the structure, as opposed to the other structures that will not fence. Our results have indicated that a total of 1,480 faunal visits were recorded across the 7 monitored structures between December 2022 and October 2024. Mammals had the larger majority of the recorded visits, representing 97% of the total records. Non-mammal vertebrates were represented by only 3%. and this was comprised of 23 amphibians, 21 waterbirds, and 1 reptile. In total, 30 species were recorded using the drainage culverts, with diurnal active species having majority of the culvert use, represented by a 66%, followed by nocturnal active species, is shown at 33.4%. Species that are active both during the day and night were least observed with a 0.7%. The use pattern of the drainage culverts were nearly equal across the day, with a 49% records during AM hours and 51% records during PM hours. Low level of human disturbance were detected at all structures. Only 43 records of human disturbance or human activity beneath the structures were observed, with majority of these observations occurring at structure reach number 1. Although our study has shown that the monitored culverts were used by a total of 80 species, small to medium-sized mammals such as slender mongoose, yellow mongoose, Cape porcupines, spotted guinea, and servals have accounted for the highest frequency and crossing index, as shown in the slide. We suggest that the reason for this could be because these species often have smaller home ranges, which may result to more periodic movements within their home range. While our study found no significant difference in the number of visits at each track between seasons, the composition of the species that use the drainage culverts varied. Structure 2 had the highest visitation when compared with the other surveyed culverts, while culvert number 4 accounted for the highest use by non-mammalian species, followed by culvert 3 and culvert 1. When we check species that are listed or that have a conservation priority in the IUCN red list, only the Cape Flores otter was found or was observed using the monitored culverts, which has a near threatened status. We also have the seagull, although it is listed least concern in the red list. However, it is nationally listed near threatened in South Africa. This also emphasizes the fact that connecting our landscape has the potential to serve what threatened species. While 74% of the mammalian species that were observed using the culvert appeared on the roadkill invert for this road section, 5 species representing a 26.2%, which were observed using the underpass culverts, were never reported as roadkill along this road section. This suggests that the structures have the potential for supporting safe animal crossing along this road if they could be modified accordingly. When we check the seasonal vertebrate faunal vegetation density along the monitored substructure, the crustal Wallis test has indicated that there was no significant seasonal difference in faunal vegetation along the monitored structures. However, high number of visits were recorded for culvert 2, which had a roadside final fencing during the wet season, followed by culvert 1 and culvert 4. Interestingly, a similar pattern was observed during the dry season, wherein the fence culvert 2, had also experienced high visitation by wildlife, followed by culvert 1 and culvert 4. In our study, We have found that the drainage culvert that had a roadside funnel fencing had experienced a greater frequency of wildlife visitation than unfenced segment, with most of the visits being complete crossings. This supports our prediction that installing roadside barrier fencing would improve crossing probability. As shown in this graph, majority of the overall visits on the monitored structures were of complete confirmed crossing. Furthermore, our results have shown that the significant variables such as temperature, distance to the next substructure, distance to water body, have accounted for 42% of the variation of wildlife use of the monitored culverts, while the remaining 58% of the variation was unconstrained. Despite temperature, distance to water body, distance to the next substructure being insignificant, they were the only recorded variables that indicated a non-zero effect on culvert use. However, we admit that missing variables such as traffic volume data, wildlife composition within the adjacent habitat, prey-predator dynamics may also be responsible for non-complete crossing beneath these structures. As such, more studies to explore these dynamics are needed. As I conclude, I would like to emphasize the fact that our findings have showed that despite existing drainage culverts not being designed for wildlife conservation, if minor alterations to these structures are made, these structures could significantly improve landscape connectivity in fragmented landscapes. As shown in our study, frequent use of these structures by small to medium-sized vertebrate species was observed, which indicates the importance of improving landscape connectivity in transportation planning. Thank you for listening, and I am happy to take any questions that you may have. Thank you so much.
I think they are on the author is on the Zoom, it looks like, so I can try to have them unmute. Let me.
All right. Thank you for that presentation.
Hello, everyone. I'm here.
Question. Thabo, this is Fraser Schilling. Thank you very much for your presentation. I was wondering, we have a hard time telling which of those species that you said were most commonly using the structures are actually common. I mean, you did talk about the listing. Are you getting any use by, are the uses of the structures primarily by species that are just very common in the landscape? Or are you getting some uses by species that are much less common, even if they're not red listed?
Thanks for the question. Well, in responding to it, I could say that we do also find species that are not common in the vicinity of this place. Although you might find one visit maybe after 4 months. So we do have them, but in low numbers. But the ones that are predominantly observed as roadkill, those are the ones that we usually see. But like, for instance, the Cape Clawless otter, I'm sure we've got 2 visits of those, and it was never recorded as a roadkill on our database. So we do come across those like visits as well. Thank you so much.
I have a question for you, Thabo. So I was interested in that you said that the culverts with water in them were not used by primarily terrestrial animals. So do those culverts with water have water all the time, or is it seasonal? And do you think if the culverts were wider and allowed for a little bit of dry space, some of those more terrestrial species would also use those? Thank you.
Thank you so much for the question. So surprisingly, we had only one structure which was wide enough, was open, which was in a form of a bridge. But however, it had a water body underneath.
So it was avoided by terrestrial animals. It was mainly used by semi-aquatic animals like your marsh mongoose. We have a lot of usage by marsh mongoose. So I could say that the condition of the structure, the substrate, was kind of like influential as to what type of animals will opt to use them. All the terrestrial animals or mammals avoided that particular structure, although it was wide enough, and we anticipated it to be used frequently because it had a small patch where animals could feed, but however, it was avoided, like it has few, like less visits by animals. But another factor that may contribute to that, it divides two farmlands. So at some point, the farm workers, they use that structure to move across the two fragmented patches. So I think those are some of the factors that may contribute to that. But smaller culverts, especially circular culverts, were they predominantly preferred by animals, or that could be because the animals that we found are mainly small to medium-sized, like vertebrates. Thank you so much.